Hi everybody, this is yet another video. I believe it's the fourth, covering section 1 of chapter 4, Introduction to Probability. Now in the previous videos we've talked about the definition of probability and the notions of probability, and we've talked about sample spaces and how to generate them using a tree structure. We only have one thing left and that happens to be the law of large numbers. And I believe I touched on it very briefly, but we're going to go over it in just a little more detail today. Okay, law of large numbers is all about empirical probability. And the law where basically you conduct an experiment multiple times, you collect, you tally all the outcomes, and essentially the relative frequency of every outcome is what we use for the probability. The law of large numbers basically says that if the larger the number of trials, the closer the experimental or empirical probability will be to the true probability. In other words, if you repeat the trials long enough, then your empirical probability will approach the actual true probability for whatever experiment that happens to be, which is a very powerful thing to say because it is the basis for almost every simulation program that has a random element, particularly perhaps the most common being the Monte Carlo simulation. So let's take a look at this using a simple dice experiment with a setup that I have already prearranged. So just give me a couple of seconds to get that set up, and then we can continue. Okay, so here we are. And here we're going to, our simulation is going to be the rolling of a dice. Okay? And we want to know, and what we want to know is we want to basically track the frequency of every single of all the possible outcomes. Okay, and we do know for this one, we know the theoretical probability happens to be. We know the probability of any side of any side is going to be equal to 1/6. Okay, so let's go ahead and roll the dice once. Okay, here we have a frequency of 1 at we rolled a 3. And right now, what we have is not very interesting. We have a frequency of 3, and the relative frequency happens to be 1. If I roll it again, I get 0.5. If I roll this 100 times, I get 0.1. I have frequencies of, well, now I have 102 total rolls. I had 18 1s, 13 2s, 17 3s, 19 4s, 17 5s, and 18 6s. And their relative frequency, the estimate of their probabilities, is getting relatively close to what the actual probability is to 4 decimal places. And that's just after 100 rolls. Let's suppose I roll this 10,000 more times. Okay, here I have 1.66, 1.69, 1.64, 1.65. They're getting even closer. Another 10,000 times. I have 1.66 here. I have a suspicion that's the best resolution that they have here. 1.65, 1.65. Let me roll this another 20,000 times. These guys aren't being very helpful. 1.7, and we're getting even closer. This one is getting relatively close. Let's do another 40,000 times. 1, 2, 3, 4. Actually, let's just go up to 100,000 rolls. There, 100,000 rolls. 1.68, 1.68, they're getting even closer. How about if we go to 200,000 rolls? 2, 3, 4, 5, 6, 7, 8, 9. And check this out. Here we are at 1.66, 1.67 given the resolution that they have, that is as close as we can get. 1.68, 1.66, 1.66. So we're getting even closer and closer. How about another 100,000? And now notice we have 1.67, that's as close as we can get with the rounding, 1.67, 1.67, and these are just a little bit off. And then with another 100,000, they are all at 1.67, except for 5, which is at 1.66. It only took 500,000 rolls to get to this point, but nonetheless, as you can see, the more you increase the more often you repeat the experiment, the closer the empirical probability comes to the true probability. Sometimes it takes a lot of experiments. Thank God for calculators or computers. but we eventually get there. I'm not going to get that thing to switch to a 7, am I? Okay, no matter how hard I try. Anyways, this is an illustration for the law of large numbers, which basically concludes this video. Stay tuned for the next video where I actually get to work on your homework problems. As always, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.